Hello, ladies and gentlemen. Today we're going to be going over simplifying radicals. In this video, I'm going to go over what I call the factor cake method of simplifying radicals. And we are going to be using prime factorization in order to factor these numbers. When we are dealing with, let's say, number 2, which is 245, we are going to do the prime factorization of that. Prime numbers are numbers that can only be divided by one in themselves. So like 2, 3, 5, 7, 11, 13. They can't be divided by anything else but one in themselves. That's probably about all you're going to need for these. So what we want to do is see which one of those numbers I just listed goes into 245. And automatically I can see that 5 goes into 245 because it ends in 5. And when we divide that by 5, we get 49. Then 49 can be divided by 7, and it goes in 7 times. And then 7 can be divided by 7 one time. Once I get what I call the candle on the top, we are done making our factor cake. And I call it a factor cake because it looks like a cake. So now what we do is we pair off our numbers. So each pair of numbers comes out of the square root as a single number. And then the one that doesn't have a pair stays behind underneath the square root. And that is the simplified version of the square root of 245 is 7 times the square root of 5. So let's look at number 4. So we're going to make our factor cake for 32. And when I do that, I'm going to divide by 2, which is 16. I'm going to divide 16 by 2. Anytime it ends in an even number, I'm going to divide by 2, which is 8. 8 is divisible by 2, which is 4. 4 is divisible by 2, which is 2. And 2 is divisible by 2, which is 1. So now I'm going to pair everything off. So I got a pair here and a pair here. When I take out those pairs, they come out as singles, but we multiply them together. And then this last 2 is going to stay underneath my radical. So we have 2 times 2 square root of 2. So we're going to simplify the 2 times 2 into 4 square root of 2. And that's going to be my answer. So let's look at number 6. So we're going to factor 200. So I'm going to divide by 2. You could also divide by 5, but I'm going to divide by 2, which is 100. I can divide 100 by 2, which is 50. I could divide 50 by 2, which is 25. I can divide 25 by 5, which is 5. And then 5 is divisible by 5 one time. So I see I have a pair of 5s and a pair of 2s. So we're going to have 5 times 2. And then this other 2 stays behind in the square root. And 5 times 2 is 10. So I get 10 square root of 2. So now we're going to move on to problems where it involves variables. So for example, we're still going to make our factor cakes. So I'm going to make a factor cake for 72, and then I'll deal with the variable after that. So we're going to do 72 divided by 2, which is 36. Then we're going to divide 36 by 2, which is 18. We're going to divide 18 by 2, which is 9. We're going to divide 9 by 3, which is 3. And then 3 is divisible by 3 one time. So I have 2 pairs of 3s, and a pair of 3s and a pair of 2s. So we're going to take the 3 and the 2 out, and they're going to become 6. So I'm just simplifying it for myself. I already know they're going to go back together and multiply. So save that step for yourself. And then we have 2 left behind, okay? Now we got to deal with this p to the third power. P to the third power is p times p times p. Pair off your p's. So I have 1 pair of p's, so that's going to come out. And then this one's going to stay behind. And that's it. Dealing with variables, honestly, is easier than dealing with the numbers. So number 14. We're going to make our factor cake for 28. We're going to divide by 2 and we get 14. We're going to divide by 2 and we get 7. Divide by 7 and we get 1. So that's the pair of 2's is going to come out. The 7's going to stay behind. And then with the x to the fourth, we write out 4 x's. We pair them up. So I've got a 2 that comes out. So this 2 goes here. These x's are going to come here, and it's going to be x to the second. And then we have the square root of 7. And that's it. So the only difference between that set of 10 and the last set of 10 is the last set of 10 has 2 variables. That's the only difference. So I'm not going to do that one. Let's look at 24. So we're going to do 27. So 27 is divisible by 3 9 times. 9 is divisible by 3 3 times. 3 is divisible by 3 1 time. So I have a pair of 3's there and a 3 that's going to stay behind. Then we have m, and then we have 3 n's. So 2 of the n's pair off. These 2 are going to stay behind. So we take the circled stuff. So we have a 3 and an n, and then a square root and a 3mn. And that's going to be our answer. So I hope you found this video informative. If you need any help or have any questions, please let me know, and have a great day. Bye-bye.